Hello everyone and welcome to session number 6 of Warwick Data Science Society's course Beginners Python. Now we're starting to work our way towards the end of this course, but there's still a lot of really exciting and powerful ideas in the world of Python to be learning, so do stick with that. Now in this session we don't have any material to recap at the start, so we're just going to go straight into learning about today's content, but if you have any questions in the hybrid live sessions, you know the drill by now. Pop them in the chat and we'll pause for a moment to answer those before we get started. So what we're going to be learning about in today's session is these things called functions. And we've used functions quite a bit. For example, print is a function, or sum or len. Anything that gets Python to do something is a function. We put in inputs and we get out an output. And we're going to look at in this session how we can make our own functions to allow us to kind of break our code up into more smaller, more logical chunks to make it easier for us to do more complicated problems without kind of getting bogged down in the details. So we're going to look at functions, some details about how we pass inputs and outputs from functions, and then some kind of more technical topics such as recursion and variable scope that are very important for understanding exactly how functions work and what common issues can arise. So with that, we'll pause for a moment to take any questions in the hybrid live session and then get started on today's content. Okay, let's get started with today's material then. So as mentioned, today we're learning about functions, and we've seen functions plenty of times before. So some examples are the print function, input or sum, and basically they're the way that we get Python to do something. It's a form of command that we can maybe put inputs into that will either do something directly or return a value to us as an output. And so functions actually aren't that unique or special. They're just another type of variable or another type of object. We've seen integers, floats and strings. A function is just another example of an object type. And actually this is a good point to mention that actually everything in Python is an object. So a function is just another example of one of these types of variables. And so the difference between a function and like a normal number, say, is that we can follow a function by some brackets, and that's going to evaluate or run that function, basically do the thing that it says it does. And inside of that pair of brackets, we can put in arguments, and those are values we put in to say how we want the function to be ran, like kind of options for the functions. And so the beauty of a function is that it allows us to run a more complicated task using a very small amount of code. Something like sum, for example. We put in a whole list. If we wanted to do that manually, we would have to loop through the whole list, take out each element and add them together to a total. We actually saw an example of that in last session, I believe. But the sum function, just 3 letters and some brackets, does it all for us. And so it's a really good way of kind of abstracting away what our code is doing into smaller, more manageable chunks. And so what we're going to learn to do today is to define our own functions. So take some functionality and kind of package that up in a function so we can call it whenever we need it. And so there's many advantages of this, the main one being that we can reuse code. Once we've created a function, we can call it multiple times as we would call print, input or sum multiple times. But there's also many other reasons of why we would want to use functions in our code. So let's look at how we would write a function. And we define a function, that's the word for creating a function, using the def keyword, which is short for define. And then we have a structure like the following. So we have def to define a function, then we follow that by the function name and a pair of brackets, and then a colon. We then have an indented block of code, and everything in that indented block is part of the function, and will be ran whenever we call that function anywhere else in our code. And so notice that when we actually create a function or define a function, that doesn't do anything. That just kind of creates it, but won't actually run it. If we want to run it, we then have to call it by writing out its name and the brackets somewhere else in our code. So for example, on a new line of code or a new block of code, we could write say_hello and then brackets. That's going to run whatever is inside this indented part of this function definition. So writing this just creates the function, and then calling it like this will actually run it. And we could call that multiple times. We see here we we say hello, we print out another line, and then we say hello again. And whenever we run say hello, we run the contents of the indented bit, which is to print hello world. Okay, so some functions we use simply for their effects. So the print function is an example. we run print with some input, and all it does is print that out. But some functions return a value. So input is an example. We run it and it will return whatever the user inputted. Or sum will take a list and return to you whatever the sum of the numbers in that list was. And so we might want to write functions for ourselves that can return values. And we do this using the return keyword. So we can place this anywhere in our function, but whenever we see a return, we stop there, end the function, and return whatever value we specified. So for example, we could create a function called 5. So we define a function called 5, brackets and a colon. Then in the indented bit, we write what the function is going to do. And this one simply just returns the number 5. And so we use the return keyword, followed by whatever we want to return, in this case, the number 5. And then what we can do, whereas before we simply ran the function by itself, what we can do here is run the function and then assign the output to a variable. And what happens here, when we run 5, we're going to get to this return statement. Python's going to return that value 5 and replace where we saw the function call 5 here with simply the number 5, which was the returned value. And so num's going to be given the value of 5. When we go to print out num, we get the number 5. That's the way we can return output from a function call. Let's have a go at applying those techniques in these puzzles here. Okay, let's take a look at the solutions to these puzzles. So we were asked to create a function called greet, simply prints out hello, and then we can call this multiple times from another function using a for loop. So the two functions we'd have is something like this. So we define a function greet, and then we simply print out hello inside of this, so this indented bit. And then we can run this function just by using greet with brackets following it. And here we get hello as the output. And I really want to kind of emphasize here, because I haven't made it explicitly clear, you need the brackets at the end to run a function. And this is kind of what I was hinting at earlier, that functions are just another object or variable in Python. So if you have the function without the brackets, it's just going to tell you about the function variable itself, but not run it. So if you want to run it, you have to use the brackets there. And so we can then create a function called greetGroup, which is going to say hello 5 times. And we can do this by calling the greet function inside of a for loop. So we loop through 5 times, and then each time we just simply run greet. And so, what's the benefit of doing this? Why didn't we just print hello inside of here? Well, the answer comes down to modularity of our code, that we've broken it up into kind of more self-contained modules. And in practice, these are way too small compartments for our code, but it kind of illustrates the general idea. So by calling greet here, we've given ourselves the flexibility to change how we greet. I could go and change the greet function from hello to hi, to howdy, to anything I want. And then this function is still going to call this greet function with whatever is being printed in here. And so this allows me to create many functions. I could have greet group, greet pair, greet whole town hall, and all those could call the greet function. And by changing what the greet function does, we could change the output of these ones too. So we're providing modularity to our code and allowing us to reuse things in multiple places, but still having the ability to change those all from one central point. That's kind of the logic behind that, and it just goes to prove, in case it wasn't clear, you can call another function from inside of another. Okay, so let's talk a bit about the terminology of a function. So over the past few sessions, I've been very vague on what those things inside the brackets are called. I refer to them as parameters, as arguments, options, inputs, various different things. But from now on, we're going to try and get the terminology right. I might make some slip-ups, but we're going to get it right at least for this slide. And so from now on, we're going to use the proper names, and we're going to use an example of the input function to understand how we do this. And so if we look at the documentation for the input function, we'll see that it has so the word for this is parameter, which is called prompt. So whenever we call the input function, we have to put in a value, and that's going to be used as the prompt, the thing to ask the user. And so internally, input is aware of this thing called prompt, and that's the parameter that we set. So parameter is just some kind of variable inside of a function definition. So when the input function does its stuff, kind of inside of that function, it's aware of whatever prompt was passed in. That's called the parameter. Now the actual value that we pass in is called the argument. So this thing called prompt is the parameter, and we give that parameter a value, and that value is called the argument. And so the argument might be the exact string that we want to be said when asking for input. So how are you could be the argument. And it's that argument that matches the parameter. And so this will be maybe cleared up a bit when we see how we can use parameters on the next slide or two. But that's the terminology. And so a general way of thinking about it is that when a function is called, a variable is created inside of that function for every parameter. And the value given to that parameter, to that variable, is the argument that we passed in that matched up with it. So let's see kind of maybe a more clear example of how that works. So we're going to want to know now how to add our own parameters and arguments. So really add our own parameters to functions. So actually this title is a bit wrong. It's very difficult to remember the difference between the two because they are very interrelated and closely related. But there is a difference, and if you can try and remember that, then that's generally better, but it's not worth sweating about. So we want to be able to add our own parameters to functions so that they can have more flexibility in what they do. And so we can do this simply by putting parameters inside the brackets when we define a function. So for example, we could create a function called square. That's going to take a single parameter called num. And then we can use this parameter as, I'll come back to that in a second. We can use that parameter inside of the function just as if it was a variable. So we can print out num squared, and then whatever value this is given is going to use that inside of our function. So think of it as a way of kind of putting inputs into our function, kind of the opposite to returning, which gives an output. Then when we go to call the function, so we can use square and brackets, we can put a number as an argument. So the argument here is the number 3, and that corresponds to the parameter of num. And as I mentioned on the last slide, essentially what happens is each parameter is, so a variable is created for it, and it's assigned the value of whatever argument was passed to it. So you could almost imagine an invisible line at the start here which says num equals to 3. Or whatever value we set as the argument. If we put 4, it would be num equals to 4. And so we get to use num with whatever value is put in here. And that's given us a lot of flexibility because now we've created a function that doesn't just do one thing, and depending on what the input of the parameter is, it will do a completely different thing. So it's a lot more powerful way of coding. And so it's possible to also give default values to parameters so that a user is free to leave those blank. And we do that using the equal symbol. And so it looks something like this. So we're going to create a function called add, and it has two parameters, a and b. But b has a default value of 1. We write this b equals 1. We typically don't put a space between this just to keep our function definitions nice and short. And so a doesn't have a default value, but b does have a default value of 1. And for that reason, we can miss it out when we're when we're calling our function. So the inside of the function prints out a plus b. If we do add with both arguments, then 2 is going to map to a, 2 is going to map to b, and we're going to get 4 as the output. So we had 2 arguments, 2 parameters, those get mapped across. But if we only put one argument in, well then a is going to get this value, but b has a default, and so we'll use that default of 1, and we get 3 printed out in the end. So b had the value of 1, we got 3 because b was not specified when we called the function. It's important you have to put your optional parameters, so the ones with defaults, at the end, so after all the ones that don't have defaults, otherwise Python will give you an error. Let's have a go at doing these puzzles, then we'll join back again in a moment to look at the solutions to those. Okay, let's have a look at how we would have done those. So the first question was about creating some code to greet a person where it's possible to have an unknown name, in which case we ask for their name. And so we can do this by having greet person with name is equal to unknown, so the default of unknown. If the name is still equal to unknown, then we print out hello, what's your name? But if a name is specified when we call it, well then this is going to have a different value, not unknown. And so we can use an else and print out hello and then whatever that name is. And so this is an okay method, but it's really far from perfect. Because the problem is, what if someone's name was unknown, like literally the text unknown? Well then, rather than going out and doing hello unknown, we'd ask them what their name is, even though it was specified. So there is a much better way of getting around this using a special object in Python called none. And you can learn more about that in the additional notes. If you aren't aware of those, please do check them out, just have a brief look. They're kind of additional notes to accompany the course that go into more detail. So you can find those on the course webpage. And so the second one was about taking a width and a height of a rectangle as two parameters to a function and multiplying those together and returning that as a value. So we could do something like my area equals 2 and then call rectangle area with two numbers, and then that returned value will be assigned to the object. So rather than just printing out as we did with these before. Okay, so we're now going to have a look at a fairly complicated but very powerful technique called recursion. And so we saw in the first set of puzzles that we could take a function and call another function from inside of it. And in fact, we can keep doing this again and again, and even do it calling one function inside of itself. And this sort of technique is known as recursion. And so recursive meaning doing something again or repeatedly. We're calling the same function from inside of itself again and again. And this is a very common design pattern. We looked at a design pattern in last session. A design pattern is basically a common way of solving a task, kind of almost a template for a solution. And it's a useful design pattern, a useful technique for solving a problem that can be broken down into a series of nested subproblems. So rather than solving the whole problem, you solve a part of it and then use that solution to build up bigger and bigger solutions until you have the whole thing. So as an example, we have the Fibonacci numbers. So for those not aware, the Fibonacci numbers are defined as we start with 1, 1, and we get the next Fibonacci number by adding the last two together. So we have 1 plus 1 is 2. The last two are now 1 and 2. Add those together, they get 3. 2 and 3 is 5. 3 and 5, 8. 5 and 8, 13. We carry on in that fashion. And so this is a really good problem for using a recursive design pattern, because we we define the problem recursively. That if I want to know what the Fibonacci number, the 10th one is, well, if I knew the 8th and 9th, then I'd be good. I'd just add those together. Well, how do I know the 8th? Well, if I knew the 6th and 7th, I'd be great. We just add those together. And so we can keep breaking it down into these smaller problems until we get to the first Fibonacci number, which is 1, in which case, oh, we're good. We can just return that as our answer. And so here is some code that is going to generate the nth Fibonacci number. So we're going to put in n, say 10, and it's going to give us the 10th Fibonacci number. And so we create a function called Fibonacci with the value of n. And so we're going to start with a simple case. So if n is 0 is kind of the first one, we're going to use zero-based indexing because it's Python. Or if we're on the second one, which is going to be index of 1, then we're going to return the value of 1. So the first two Fibonacci numbers are 1. Those are the simple cases. Now, if we don't have a simple case, well then we're in a more complicated case, say the 10th Fibonacci, in which case, how do we calculate that? Well, we calculate the 8th and the 9th, and then add those together. And so that's exactly what we do. We return whatever the sum is of 1 less than the current number we're on, and 2 less than it. And so these are then going to run their own versions of Fibonacci with a lower number. And those are gradually going to get lower and lower until we get to 0 and 1, in which case we finally finish with 1, a definite answer. Those then build themselves back up, getting added together until we get right back to where we started. So just to illustrate kind of what's happening there, so we start with Fibonacci of 10. That's not 0 or 1, so we're going to call 8 and 9. Well, let's look at what 9 does. Well, 9 is going to run through here. It's not 0 or 1, so that's going to call 7 and 8. And what 8 will have done is do the same thing, but called 6 and 7. And that's going to keep going down, 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 making this massive tree of all these answers. Then they're going to get all added up right back to the start. So it's really quite a beautiful way of coding. All that kind of complexity is just captured by the simple 3 lines of code here. And it works. We can put in Fibonacci of 10, and we get, this is actually going to be the 11th Fibonacci number because we're using zero-based indexing. So we have 89 here. So let's have a go at some recursion. We're going to look at the factorial. If you've not seen this before, so a certain number factorial means take that number and times it by all numbers that are less than it. So, for example, 5 factorial is 5 times 4 times 3 times 2 times 1, which comes to, what's that going to be? 120. And so we're going to try to calculate these. Factorials are really important when it comes to kind of counting problems. How many ways can we arrange some people at a table so we have all the different combinations of that? And so this is a problem that can be broken down recursively, because if we want to find out what n factorial is, say 5 factorial, well then that's 5 times 4 times 3 times 2 times 1, which is just 5 times 4 factorial, because 4 factorial is 4 times 3 times 2 times 1. And so if we want to know n factorial, all we need to do is calculate 1 less than it factorial, and then times that by whatever number we're on. So we can keep breaking down the problem into smaller and smaller subcases. So we're going to have a go at that. It's a bit of a complicated problem, so don't worry if it doesn't come to you straight away. We'll have a look at the solution after. But give it a go and see how you do, then we'll join back in a moment. Okay, let's have a look at how we would have done that. So even though the solution is only a few lines of code, conceptually it is quite difficult. So if it took you a while to do it or you couldn't do it at all, not a problem. Simply you'll come back and have a look at this at some point soon in the future and see if you can do it then after seeing a look at what it looks like now. So we're going to create a function called factorial. It's going to take an input of n, the number we want factorial. And so if we have n is 1, well then what is 1 factorial? Well, it's 1 times, we're done. So it's just 1. So if n is 1, then we return the number 1. Now otherwise, how would we calculate, say, 6 factorial? Well, we take the number 6 and then times that by 5 times 4 times 3 times 2 times 1. Oh, but that is just 5 factorial. So we times 6 by 5 factorial, in other words, the number we're on times by the factorial of 1 less. And if we keep doing this, then eventually we'll get to 1, and then things will all bubble up to get the answer we wanted. So factorial of 4 is 1 times 2 times 3 times 4 is 24. It works as expected. Let's just break down what happened there. So factorial of 4 is 4, 1. No, so we do 4 times whatever 3 factorial is. Well, 3 factorial, is it 1? No, we do 3 times whatever 2 factorial is. 2 factorial, is that 1? No, so we do 2 times 1 factorial, 1 factorial. Oh, that is 1, we return 1. We then do 1 times where we had a 2 left over, so we do 2 times 1. That's then the answer that goes with 3, then that one goes with 4, it all bubbles the way up until we get 24 as the answer. So it's a bit of a confusing idea, but have a think about it, kind of break down what it's doing step by step, and hopefully it'll make sense. Okay, so the final thing we're going to look at is variable scope. And this is a notoriously difficult problem in any coding languages, but it's also one that's going to give you a lot of trouble, so it's worth being aware of just so you can kind of understand how it works and know how to fix it. So when we define a variable, we define it at a specific scope. And a scope basically refers to where the variable exists. And the reason we have scope is so that we're not having the same names bump into each other. You could imagine a case where, or for example, so when I use a certain function inside of Python, let's say it's the sum function. Inside of the code for the sum function, which is somewhere on my computer, it was written by Python developers, I don't know what it looks like. That might create a few variables. What if the variables that were created had the same name as a variable that I already had in my code? That could be disastrous. It could overwrite my variables, I could lose my data. But because of scoping, that doesn't happen. The variables in that function have their own scope and don't mess with mine. And so it allows you to have variables of the same name without them messing with each other. And so it's a very useful idea, but it can lead to some trouble. And so whenever we define a variable in the main body of our code, so just inside of a generic cell, not inside of a function, then it's given a global scope. And that means it can be accessed anywhere, including inside of functions. But if we define a variable inside of a function, then its scope is local to that function. It doesn't exist outside of the function. And so if we try to use it after, that's not going to work. Instead, what we would want to do is return the value, and that lets us access things from inside of a function. So for example, a bit of a lengthy code here, let's break it down. So we create a global variable called global, and what makes it global is that we created it at the top level of our code. We then have a function called myfunc, and it creates a local variable, and this variable is local to that function, called local, and then prints out local var inside of the function. So we run the function, we print global var, we print out local var. So we print out, so we first run the function, that prints inside a function local, so that's great, local exists. We then print outside the function global var, that works fine, we get global. But then we try to print out local var from outside, and we get an error, it doesn't exist. Because local var was created in this function and only exists inside of that function. And so this is going to give us an error. Instead, what we might have wanted to do is to say return local var, and then assign the output of myfunc to maybe local var, and that's a global version of local var, so we can use that outside. And so when we access a variable, so we try to get a variable's value, the scope is going to be searched from the innermost scope to the outermost one. You can think of that as the most relevant scope, the one I'm in, to kind of the most global, anything scope. And so this allows us to reuse names inside of a function, but do be careful doing that. It can be unclear and confusing. This is more of a measure they put in place for if you're using other people's code that might have names you're not aware of. It's not a reason for you to deliberately try to have the same names inside and out. So for example, just to illustrate this point, terrible code here, but it illustrates what can be done. We have a variable n. This is a global variable n called 10, with a value 10, sorry. And then inside of this function print20, we set n equal to 20 and then print out n. So this n here and this n here are completely different variables. This is a global one, this is one that's local to this function. And so we can print out 20, it's going to set n equal to 20, print it out. That's a different n to the one out here. So we go to print out n in the global one, we still get the value of 10. And the reason that this n here refers to the inside one is that scopes are searched from the most inner one to the most out one in that order. So we start by looking in the current scope. Well, there's an n here, great. If we hadn't have defined n, then we would have printed out 10 instead, because we'd keep going up levels until we found a match. If we didn't find a match at all, well, then we get an error. Let's have a go at these puzzles, kind of contemplating how scope works, and then we'll join again in a moment to look at these solutions to those. Okay, so to wrap up the session, let's see the answers to these questions. So the first code here, we wanted to know what would be printed out by A in both places. So we set A equal to 2, so that we have a global variable A here, and then we run this double here. And what double does, it takes a number B and sets A to be equal to B times 2. And so this A here is a completely new A, it is a local one, not the same one here. So A is going to be given the value of B times 2, which is going to be 5 times 2, 10. So we print out 10. That does not affect the global one. This is its own variable in the local scope. And so we get 2 when we print out A at the end. In this example here, we were asked to rewrite this code to avoid referencing the global variable n. So rather than using this n through the global scope, we could instead pass it in as a parameter, or as an argument, sorry. So we have n is equal to 10. When we call square, before we just call it like this, and then reference the global variable. In this case, we just put the value of n in, and then use that inside. And this here is the parameter. This is a local variable different to the one outside here. So we could modify this n inside here, wouldn't be a problem, would not affect the one outside still. But this is a much kind of cleaner way of doing things than referencing something that doesn't exist in the function and having to search upwards. And so you may want to know, well, how could I maybe modify this outside one? That's not something we've looked at here. And again, I'll point you to the additional notes. We'll look at this thing called the global keyword, which lets you modify a global variable from inside of a function. Generally bad practice, but if you want to do it, we'll show you how to do that. So with that, that's the end of today's content. Look forward to seeing you in next session, penultimate session, where we're going to be looking at a new type of data storage called a dictionary. It's going to solve a lot of the problems we saw with lists, so looking forward to sharing that. See you then.